Federal agencies say they're taking a two-pronged approach to AI and cyber. Jeff Crume is studying those two prongs. He's cybersecurity architect and distinguished engineer and chief technology officer for IBM Technical Sales for the Americas. He's author of Inside Internet Security, What Hackers Don't Want You to Know. Jeff, welcome. Thanks very much for joining me. The two-pronged approach that I reference is the use of artificial intelligence in cyber defenses and how one defends the artificial intelligence tools that one uses. What's your sense of how people all across the spectrum are dealing with that intersection of cyber and AI today, Jeff? Welcome.
Yes, thank you. My sense right now is that we're all still trying to figure it out. I have a feeling that it's like when I was an undergrad many years ago, back when dinosaurs still roamed the earth, and I was taking a course on computer graphics, and it was very clear that the professor, who was very brilliant, had really just read one chapter ahead of us in the textbook. And I feel like that's where we are when it comes to AI these days as well. It's like the ones who qualify as subject matter experts are kind of the ones that read one chapter ahead, but the rest of the book still hasn't been written. So I think of it this way. I know for sure the bad guys are going to start using AI to automate their attacks. We've already seen the example of where we know AI can write code. Well, why wouldn't it be able to write exploit code? Why wouldn't it be able to write malware? Well, of course, in fact, it can. And we're going to see, I suspect, more of that. So we're going to see the bad guys using this as a tool to up their game, which means the good guys are going to have to use it as a tool to up our game and use it as a force multiplier so that we're more effective. And then there's even a third rail on this whole thing, and that is that the organization is deploying AI, sometimes knowingly, sometimes unknowingly, and we're going to have the job of securing that new attack surface. So the job of doing security just got bigger because now there's this whole AI attack surface, and we've got an issue of shadow AI that people are starting to just, okay, it's really easy. I can just go to a cloud, spin up an instance, and throw in some models, and we're off to the races. Oh, but nobody secured that yet. So there's a lot going on here, a lot on our plates these days.
Shadow IT is something that the federal government's talked about for as long as I've been following the federal government, almost 20 years. Is the problem with shadow AI the same as the problem with shadow IT? Is the risk vector the same, or is it different because of the different technology involved?
I say it's very similar, very analogous. The idea that somebody might just bring in a device and plug it in, this is the same kind of thing. Now they bring your own cloud. Well, bring your own AI, deploy a model in that cloud instance. So that means we're going to have capabilities to go out and discover the uses of AI in our environments, because not everyone's going to tell us in every case all the stuff that they're doing. They thought it was harmless, but how it may not be harmless is if they are using training data, they're gathering data from lots of secured sources, and they bring it all together and aggregate it in order to train or tune a model. Okay, good, but did they carry forward the same security protections? And the chances are, in some cases, they didn't. We've already seen examples of that. So that means they actually made the job easier for the bad guy. They not only pulled together all the good stuff, then they put it in a publicly accessible place, and then it's like game over. We just served it up for the bad guys on a platter. So we want to make sure that the models also that they're pulling down, most organizations are not going to develop their own models. They're going to pull these from other sources because they don't have the resources to develop these themselves. So they're going to go to an open source repository like Hugging Face that has more than 700,000 AI models on it today. Now, who has vetted all of those from a security standpoint? I guarantee it hasn't been. Some of those have trillions of parameters, not millions, not billions, but trillions of parameters in them. And nobody has the time to, no way you can manually examine all of that. So those are the things that we're bringing in, this kind of tooling into our environments. And from a security standpoint, every single one of those things is another degree of freedom that might be something that would be broken into. Now, it'd be really easy to be negative on all of that. I'm not, believe it or not. I just know that this is going to be a lot more of a challenge for us. But I think the promise of AI is quite interesting for us.
Regarding shadow IT, people have tools that they can use to see and stop instances of shadow IT on their networks. Does anything like that exist for shadow AI, or can something like that exist for shadow AI?
In fact, we just came out with the capability to do it. And I just produced a YouTube video, or I didn't produce it. I was the subject matter, guy on the screen, and there's a whole bunch of other people that actually made the production work on exactly that subject of shadow AI. So I'll encourage people to go take a look at that. One of the things I do for IBM is we have an IBM technology channel on YouTube. And I've got just about 100 videos out there right now. And one of the most recent that just came out was on shadow AI. And I don't, on the channel, we don't talk about products, and I'm not going to go into detail. This is not a sales pitch here. But I talk about capabilities and what are the necessary capabilities for people to consider. And so that's what I cover in those videos. So don't be worried you're going to be bludgeoned over the head with a marketing message. It's technical content.
Another wrinkle here in this is the potential volume and speed at which quantum computing will be able to execute some of these things. What are the implications for that? And how does one think about when one should be ready for that onslaught, given that we don't know exactly when quantum computing will be a thing, I guess, is the best way I can think to describe it.
Yeah, exactly. No, I love this question. Quantum computers are going to do some amazing things for us. I truly believe they're going to save lives. We're going to be able to model what kinds of things happen with pharmaceuticals, what kinds of things happen with the weather in a greater degree, all kinds of things that required simulations and modeling that we just couldn't do with today's classical computers, we'll be able to do with tomorrow's quantum computers. But one of the problems that they're also able to solve is this business of factoring large numbers. And you say, well, why do I care about that? Well, because that's the basis of our asymmetric cryptography that holds together, what we do on all public networks and even private networks these days. So the bottom line is, eventually, someone with a sufficiently strong quantum computer will be able to read all the messages that they've gotten a copy of using today's cryptography. So the good news is the National Institute of Standards and Technology realized that in advance and has been working on coming up with new quantum safe or post-quantum crypto standards. And they've come out with 3 that they've announced for sure, and there's a 4th one that they're still working on finalizing. Just as an aside, IBM contributed to 3 of those 4 IBM contributions, and we hired a guy that worked on the 4th one. So we've been trying to work on producing strong quantum computers. We're also trying to work on the solution to one of the side effects that they create. And in terms of when do people need to start caring about this? Well, the actual answer, it's going to sound facetious, but was yesterday because of an attack called Harvest Now, Decrypt Later. If I make a copy of your encrypted data today, maybe I copy your database or I sit on a network and make copies of the encrypted messages you're sending, I just have to wait for the future to come to me, and eventually I'll be able to read all those messages. You will not be able to go re-encrypt my copy. You can only re-encrypt your copy. So I sit on my copy until the quantum computers are fast enough, and then I'll be able to read it. And that's why people actually need to be starting now. You cannot afford to wait until quantum systems are strong enough, because that's when you're going to wish you had a time machine. And then you could, jump into that and go back and re-encrypt everything. It'll be too late at that point.
How does one know how strongly something must be able to be encrypted in order to be protected far enough into the future that the information is no longer relevant?
Yeah. So this is a really important question. The cryptographers, which I am not, say that our symmetric algorithms, we'll just need to double the key lengths of those. So AES, the advanced encryption standards, the most common that we use in that space, we'll instead of using 128-bit key lengths, we'll start using 256-bit key lengths, and we should be good, all the experts say, for the foreseeable future. The asymmetric is the really big one. That stuff's just going to be broken. And we can't just double the key size and get away with it. That's why we needed these new algorithms. And by all accounts, the NIST started this work in 2016. And so we've been looking at this now for 8 years. And so far have these algorithms that are the finalists have withstood the challenge. So we believe that they will be able to withstand, and they will be strong enough. One of the side benefits is they're actually a little faster than some of our existing algorithms. So not only will we get better strength, we'll also get a little bit better performance. And the other thing that a lot of people get confused about is you can use a classical computer to use these quantum algorithms. So in other words, you don't need a quantum computer to overcome the quantum attack. You can use a classical computer, use these new quantum safe algorithms on the classical computer, and guard yourself against the future attacks.
How far do you think we are from quantum computing having some kind of direct influence on what people are doing on a day-to-day basis?
That's also, that one's highly speculative. I think most people think, especially when it comes to what's been referred to as Q Day, the day when quantum computers will be able to break crypto, that's probably 5 to 10 years away. That's if everything projects linearly. And if the past is a predictor of the future, which sometimes it is and sometimes it isn't.
Yeah.
That's just literally projecting out the growth that we see, sort of a Moore's Law version of quantum systems and their strength. If all that holds true to form, it's probably in the 5 to 10 year range. But there's this huge caveat. Somebody may find a backdoor sooner. There's already been a couple of false alarms where researchers, in one case, said we can, with today's classical computers and today's quantum computers, use a hybrid approach to break asymmetric cryptography. Now, it turned out that it didn't work, but the point was we got the warning shot across the bow. Someone may discover one of those things tomorrow, and suddenly the whole thing falls like a house of cards. But we're looking 5 to 10 years, barring something like that happening.
If you were advising a leader in the federal government sitting across the table from us, and that person said to you, what should I start doing today, given that yesterday was the best way to start thinking about encryption? What should I start to do today to make sure that I'm as protected as I can be from all of the threats that we've talked about on this conversation?
Sure. So on the quantum part, what I would say is first, start doing, if you haven't already done it, a good data discovery and classification capability. Use tools to do this. You might think you know where all the sensitive data is. You probably don't. So make sure you're running tools that can help go out and discover where the sensitive stuff is. Second is create what we refer to as a crypto bill of materials. Know where all the cryptography is used in your organization, what algorithms, what key strengths, what data is being protected, where the keys are stored, all of that kind of stuff. Build up that inventory list. Because when we start doing the conversion, the re-encryption of this data, we're going to need that as our guide. Then you can use some tooling to help you develop a program, because this is a multi-year process. Nobody's going to flip the switch and be quantum safe tomorrow. If you start doing that cataloging, you're going to find you've got crypto all over creation, and you can't just go flip the switch on all of them. You're going to have to prioritize, and then you're going to need to track. So you're going to need a program. You're going to need a project management team. This is going to be a big thing. Okay, so that's on that side. On the AI side, it's more right here and now without debate. That is, we've got to discover our uses of AI as much as we can. We've got to make sure that we've got them locked down. We've got to make sure that the organization knows that, yes, we can use AI, but how we go about doing it in an ethical and secure way is going to be paramount. So develop those policies, procedures, get the tooling that supports it. If you don't have the tooling, you're not going to get there. It's just there's not enough people we can throw at this problem fast enough that way. But then also start looking at how you can leverage AI, especially generative AI. We've been using machine learning in cybersecurity for years, but how about generative AI to improve cybersecurity outcomes? And I think there's a lot of interesting. I've got a couple of videos on exactly that subject as well. That I think the promise is good for us there.
Jeff, it's great to talk to you. I really appreciate your time today. Thanks for helping me understand these issues a lot better.
You bet. My pleasure.
You can read more about AI in government on today's show page at fedgovtoday.com.